about electron displacement effects in covalent bonds. Electron displacement effects in covalent bonds. Okay, now how many types of covalent bonds are there? Any idea? Types of covalent bonds. Types of covalent bonds. Can you tell me how many types of covalent bonds are there? Hello? No idea. Say something, whether you know or don't know. Don't keep quiet.
Sir, 2.
What are those? Tell. I'm there to correct it, nah? If you feel shy, you cannot learn anything.
Non-polar.
No. There are two types of covalent bonds are there. These are sigma bond and pi bonds. Okay. Sigma bond and pi. You remember how the sigma bonds are formed? You remember? See here. Sigma bonds are being formed by the head-on overlap. Okay? So it is like this. This is the way you get. This is the sigma bond. And pi bonds are formed by the overlap of the p orbital. So what you get now here? Or this one you write like this. This is the upper lobe and this is the lower lobe. So these are the pi bonds. Okay, see here. Sigma bonds are strong because they have maximum overlap, and pi bonds are weak because they open up. Please write. Then after that we'll discuss. Everything you should know. And these are not difficult. So now let's see. So when we say electron displacement along a covalent bond, so say this is the covalent bond we are having it. Say something like this. Okay? So see here. This is the electrons are there here. Because we know this is a covalent bond. So one of the electron belongs to this carbon, other it belongs to this. No? Displacement means movement. So either it can move in this way or it can move in this way. So this is electron displacement along a sigma bond. Don't write. Now, another one. See here. Here also you have electron. See, if this is sigma bond, always remember, first bond formation is always sigma bond. Then this is the pi bond. So here also you have electron. So this electron also can move in this way or in this way. So this is the electron displacement along a. Okay. So now what we can write here? We can write here sigma electron displacement. Here we can say pi electron, but pi electron has nothing but what? The pi electron is nothing but the electron of the p orbitals, or p electron displacement. So these are the two things that you are going to study. Okay, now right. We are going to study first this one. So write down electron displacement along a sigma bond. So we'll write here now electron displacement along a sigma bond. Okay, this is not being given in your book like this, but let us try to know. The simplest way to know it. Or what is this called? We call it inductive effect. Okay? Acha, now dear, tell me. Say I want to displace this electron. Okay, I want to displace this electron. Then how to displace it? Forget about electron. Suppose you have kept something on your table and you want to displace it. So how many ways you can displace it? Suggest. Tell. You want to move something, you want to displace. So how many ways you can displace it? Tell. What happened? Why everybody remains quiet? I don't understand. Huh? You always think that others should give the reply. No, it cannot be like this. Tell. Kinsha is there. Hello. What is this? This is pulling. All right. And what is the other one? We'll push it. Now these are we are talking of electron. So what type of thing can pull electron? What type of element or what type of substance will pull electron? Because please remember this is a bond pair. We have studied already in periodic table. What type of substances or what type of elements will going to pull the electron?
Element with high
Yes,
electronegativity.
Yes.
Element with high electronegative.
Yes, exactly. That is, if X is an electronegative element, or if it is a group of electronegative elements. So in that case, if you say electronegativity is a property of an element. But if it is a group of elements are there, then we do not use the words electronegativity, but we call it electron attracting group or electron withdrawing group. Okay. So let me first explain, then after that I will tell you. So if X is an electronegative element or it is an electron withdrawing or attracting group, so it is going to pull electron. Okay, so let me again draw it. These are easy. Okay, now see what has happened. Electron has gone here or not? As the electron has gone here, this X has become rich in electron. Then what will happen to the fate of this carbon here? The carbon has lost the electron. I am not writing plus and minus. Why? Because the bond is not broken. We are not talking about the bond cleavage. Okay? So in that case, moment this carbon has become electron deficient, now the carbon wants to get back the lost electron. Then it tries to see, here also you have bond pair, here you also have bond pair, here also you will have bond pair. Then the carbon starts pulling this bond pair towards itself. When it displaces little bit, then this carbon also become the electron deficient. But here you will find the effect is will be less than this. Then this also will try to pull electron from here. Okay, see now. But after that, the effect will be so less, it will not be felt. So this type of inductive effect is known as plus I. Sorry. We call it minus I inductive effect, or simply call minus I effect. Okay. So what should I write? So in that case, you can write it in this way. When carbon atom is bonded to an electronegative element or an electron withdrawing. See, these days, we call them as electron attracting. Group. the displacement of sigma electrons takes place and renders and the carbon atom becomes electron deficient. In order to overcome electron deficiency, the electron deficient carbon atom pulls bond pair from neighboring bonds and makes neighboring atoms electron deficient. This phenomenon generally disappears after third carbon this is known as minus I inductive effect or simply minus I So this one you have written. Drawn. This one did you draw? Hmm? Hello?
Yes, sir.
Yes,
Okay.
sir.
Then let us see what are these X. So X is equal to halogen atom. Okay. Example, fluorine, chlorine, bromine, iodine. So these are the elements. Now, other than that, what you have? Groups. NO2, nitro, NO, nitroso, cyanide, then carboxyl, then ester, amide, then aldehyde, then ketone, etc.
Done, sir.
Now the situation will be reversed also. Suppose we are having here Y. Okay? So it is having a pair of electrons. And here you have the bond pair. What is this? We call it lone pair. And what is this? We call bond pair. Then what is going to happen? For the lone pair or bond pair, their charge is negative. So will they attract or will they repel?
Repel.
Yes. So the repulsion will take place. What will happen? See here. In this case, you will find electron will move towards this direction. It will be like this. It will be like this. This will be like this. It will be like this. Okay. So this phenomenon is called plus I. Okay. So what we can write? If a carbon atom is bonded to an electron-rich group, then repulsion occurs. Repulsion of the bond pair occurs resulting accumulation of negative charge on neighboring carbon atoms. This effects disappears after third carbon this phenomenon is known as plus I inductive effect or simply plus I. Hmm? Okay, first you finish, then I'll explain, then I'll give you the example. Here. See. What is this? This is alcoholic group, na? Okay. Now, what is this? This is called alkoxy, or we call it ether. Then, what is this amino group? Okay. Then you can have alkyl. So these are there. Done, written. In your life also such thing happens now. So what are the things that attracts you? Tell me. One male and one female will tell. Achha, now Gitanjali, tell me, what are the things that attracts you? For which are the things you are getting attracted? Attraction means you love, you like. What are the things? It happens in our life also. Tell. What happened? Don't know. Suppose in our life, what are the things that attracts us? Yeah, we like good food. Is it not? Good clothes, good friends, companions, mobile. These are the things you like. Hmm? You like to go to a new place. And what are the things you don't like? First of all, you don't like a teacher. Because moment teacher is there, you find it just scary object is there. Huh? How many of you like teachers? Tell me. Hello? Do you like a company of a teacher? Hmm? Najia? Najia, are you there? Hmm? Are you there? Mulika?
Yes, sir.
So, do you like a company of a teacher?
Yes, sir.
Hey, Tom Bro Misawata Kosna. Huh? Do you like to sit with a teacher for hours together as you sit with your friends? Huh? Okay.
No problem, sir.
Acha. Vitanjali, do you like homework? Hmm? Hello? First language, how can you define inductive effect? Initially, I just told you, but I did not write the definition of inductive effect, though I have told you about the plus A effect, minus A effect, but in one sentence, what you are going to write? Inductive effect. Hmm? In one sentence, how you are going to write inductive effect? Tell me. So much thing you have written now. So, displacement of electron of bond pair electrons along a sigma bond is called inductive effect. Simple one. So many things might be written in your book. This is the summary of it. Displacement of bond pair electrons along a sigma bond is called inductive effect. And if it moves towards the group, making the neighboring carbon electron deficient, we call it minus I effect. And if it undergoes repulsion and makes the carbon electron rich, then you are going to call them as plus I effect. Okay. Now we are going to, we'll go for now. Displacement of electrons along a pipe. Okay. See, suppose I have taken an alkene. You have a bond between, you have a pi bond between two carbon atoms. কি?
তোমারই বেশি না লকডাউনের মধ্যে তখন এরকম বলো না এই মাসে তখন যদি
So in this case, see here, if yes, because they both the carbon having the same electronegativity, here no displacement of electron will take place. So if you have an atom like this, oxygen, see oxygen is here more electronegative. So in this case, what will happen? As I told you, the pi electrons are overlap is very, very big. Immediately you will find, so this is the pi electron. Okay, this is the sigma bond, and this is the pi. So this will immediately get displaced towards the more electronegative element. Okay, so what is going to happen now? You will find both the electron will go here, and this will become electron diffusion. As the electron has migrated, see this electron belongs to oxygen and this electron belongs to carbon. As it is migrated, so in that case I have to put one negative charge. Okay, so this type of phenomenon is known as mesomeric effect. In your book, they have initially did not mention any more mesomeric effect. They have started with resonance, but actually this is called mesomeric effect. And this is a permanent effect. Okay. So what should I write here? The displacement of pi electron towards more electronic element is known as mesomeric effect. This is a permanent effect. So this can not only happen with oxygen, it can happen with nitrogen also. It can happen with sulfur also, because they are all more electronegative than that of the carbon. Okay, so this effect you can find this See, we can write like this. This. Like this.
ওর ইয়ের অর্কিডস গুলো এত সুন্দর, ও নিয়ে গেলেই পারে, ওদের ঘর এত সুন্দর।
Yes, sir.
Okay. So now we'll go for resonance. Because when you find a single structure of a molecule is not able to explain its total property, then we have to take the help of several structures. Okay? And that phenomenon is known as resonance. Just like that, if you look at a human being, for a one glance, you cannot interpret his total behavior. You have to remain with him for some time, and you have to see his change of moods in under different conditions, the way he speaks, the way he behaves with others. Then only when you see his different facets of life, then only you can say that the person is like this. So similarly, there are several molecules are there whose only one structural form is not able to explain its total property. Okay, so we have to draw its several structures, and that is called the resonance. All right. And how does the resonance occurs? The resonance occurs because of the movement of the electrons of the pi electrons or the electrons of the p orbitals. So initially, in our chemical bonding chapter, which I have discussed in detail with you, see here, this is called carbon. Okay, in carbonate, in that case, you find that carbon oxygen has two single bonds, carbon oxygen single bonds, and one carbon oxygen double bond. So actually, when you measure their bond length, you are supposed to get two types of bond: one carbon oxygen single bond and carbon oxygen double bond. But actually, when we have taken the X-ray of the molecule, we find only one type of bond is there. And we have also learned in chemical bonding, the single bonds are longer than double bonds. So here we have found that here the bond length that you get only one type of bond length. It does not, it falls in between the single bond and double bond. Then how it can happen? So it can happen only when, see this electron, whatever I have drawn it here, this belongs to the p. So what happens now? See, this p electron is moving and taking part in the pi bond. So what you have got now here? So this is the one. Then this. See here. So every moment you find that bond, nature of the bond is changing. So what is happening now? We find the electron is continuously moving from one place to the other. See, they do not have any fixed double bond and they do not have any fixed single bond. Okay, why does it happen? Because the continuous movement of the electron is taking place. So in that case, this is the resonance. Okay. So now here in this case, suppose I have taken here See, this is on-side. In this case, see, in this case, it has two carbon-carbon double bond and carbon. This is one carbon-carbon single bond. But we find here again also you get only one type of bond. How it is possible? See here, this electron comes here. This is this. Then after that, this electron goes here. So what you get now here? See here. So it also requires double bond character. So this is the resonance. Benzene. This you have already done in chemical bonding, and I have explained to you also. Actually, those days I think there are two persons who are not there when I was explaining to them. One is Mr. Rani, and second one is Miss Pal. This. So this is the resonance for benzene. Okay, now as we have seen, we are having plus I and minus I inductive effect. Resonance also has the same thing. Okay, my mobile charge is almost going, so let me draw it. See here. So in this case, see, suppose it is having an electron donating group. See here, pair of electrons are there. So it is going to push electron here. This electron is given to the ring, so it has loss of positive charges there. So you will move the arrow from the double bond inside, not from bond outside. See here. Then it will go, and electron will go back to the oxygen. So here you will get this. This is called plus R. Now we'll go for the electron withdrawing group, which will pull out electron from the benzene ring, and that will be minus R effect. See here, nitrogen is electron withdrawing. This oxygen will first pull electron from this nitrogen, and nitrogen become electron deficient. Immediately, this nitrogen is going to pull electron from here.
স্নুপিটা এমন বলবো ওখানে ওদের বৌদিতে বসে বিড়াল বসে আছে ট্যাঙ্কির উপরে, এদিকে রেলিং এর থেকে একটা চুপচাপ করলো, আর বিড়ালও চুপচাপ বসে আছে, বিড়ালও জানে যে কি করছে।
This is the minus R resonance effect. Okay, right. Only 4% charge is there.